Okay, all right, day one of environmental chemistry. Let's have a look at what our resources are. We're going to use this book, Baird and Can. It's not a particularly thick book, it doesn't have very many chapters. It's kind of a small format and the words are large. So, all in all, not a lot of content in this book, which is fine. And we'll more or less limit ourselves to it. In reading in reading the contents, hey, come in. I was looking specifically in the book for a couple of things and I didn't find them, so there might be an occasional time that we wander outside of the confines of the book, but it will always be for things that are already pretty much established and are well known in other places. Okay, so there won't be anything strange. Syllabus is up on Blackboard, but I see this class as being so malleable, being changeable, that we can make that be whatever we want. I've put in that we would have 3 exams and a project. So technically this class comes with a lab. This class hasn't been taught at this institution in at least a decade. Whatever the labs were, they're gone. But we do know that there are a few things that we want to use our resources for to perfect for other arms of the university, your water quality thing. So there will be times when we'll come in and we'll fix a date that works for everybody. So we will be in and out. It won't be every week is a lab time. We're going to come in, we'll do something for a purpose, and then that'll be fine. And then I think we can even throw a couple of other, not just like a project that we do ourselves, probably in the area of water quality, but also like, as I said, there's a couple of things in the book that I was looking for and I'm missing. And this is an opportunity to just go to the greater resources in the world, the internet, and say, tell me this. And then Dr. Johnson has the science symposium that comes around every term. We could easily throw 1 or 2 posters at that symposium and just bulk out what's going on. Okay? All right. Make sure you all know each other.
Bryce and Daniel. Good to meet you.
Nicole.
Bryce.
We all had physics
Yeah.
together, right? Yeah. Cool.
What happened to your friend that went to Auburn? Is he doing anything?
Santi?
Yeah.
He's still there.
Okay.
He's 1 more semester.
Good.
But yeah, he's enjoying it, so
All right, cool.
yeah.
Oh, Alabama.
Mm. All right, so this is our book, and it's typical for the time in which we live. The chemistry is run in this country by the American Chemical Society. And the American Chemical Society has an approved textbook for their introductory chemistry class. And I took a look at it one year and just said, I would never ever teach out of this book. Because the tone of the book is, we apologize for what we did to the ozone layer. We apologize for what we did to the greenhouse gases. We apologize for this and we apologize for that. And in the context of how history works, we had no idea at the time. At the time, we had absolutely no idea. And even with hindsight, it's difficult to figure out how could you have known. Because this, we'll dig into this as we go, but like the science just did not exist at the time to predict what the side effect of the wonderful thing that we were doing was going to be. Now, sometimes things are just too good to be true. So I said, I had this other book. We got this book from the library when the library closed down and gave all of its books away. I picked this one up. And I said, I thought this was from the 1950s. It's actually from 1973. And this book could never be written today because it says things like, plastics are going to be the savior of society. Yeah. It just says, there's modern chemistry is so fabulous, we're going to save the world, and we're going to save the world with plastics. It's great. It's a little time capsule in itself, and you know, the fact that it is a time capsule is the only thing that's stopping it from going in the trash, because because time gives us perspective. So our book jumps in straight, chapter 1. There's a hole in the ozone layer. Let's talk about it. That's great, but it shouldn't be chapter 1 in the book, because we need to kind of assess, do we even know what ozone is yet?
Mm-hmm.
Do we know what the atmosphere is yet? Let's kind of spend a minute thinking about what those fundamental things are, and then put into context why we're concerned that there is a hole in the ozone layer. Why is that even an issue? And in order for it to be an issue, we have to understand the chemistry of the atmosphere as a mixture of gases. Concentration deviations that are fueled by complex, radical reactions that have their answer in the world of kinetics. Kinetics is the study of how fast the reactions work. And then their impact, their cause, and their impact on ultraviolet radiation making it to the surface of the planet, versus being in the upper atmosphere. So there's an awful lot to unpack there. We are not going to be ready to do that on day 1 of this class. Okay, so I think we're going to spend a little bit of time feeling around and trying to just get a sense of why this should be a topic in of itself. Why is not just chemistry a topic? Yeah, that's kind of obvious, but why would environmental chemistry be its own thing? And what are our concerns, and how do they fit in the big scheme of things? Okay, so let's just kind of do that until we feel comfortable, like, hey, I'm good enough to move on, and then we'll hit the book. So we might spend a couple of days doing this. Don't know.
Okay.
Depends. So, the book is a product of its time, and our time right now is one of concern for the environment, right? So let's think what are our concerns, and if we make a great big list of them, can we classify them and subdivide them into different sub-lists so that we can tackle them? Because two things might be allied to each other.
Mm-hmm.
Okay. What do we like about the environment that we would like to keep?
You're like, well, I guess talking about the balance of the individual ecosystems.
Okay.
I guess, right? Yeah.
Can you elaborate a little bit?
Okay, so different effects on the environment, like pollutants in the water systems can affect the ecosystem. I don't know, that's just a big blanket statement, so let's see about this.
You said water system, I'm
Uh,
going. Do I leave that as system or do I specify that that is supply? Because are we worried about everybody's water or are we only worried about our water? Because if I said water supply, that means us, doesn't it?
Mm-hmm.
But if I say just system,
Water system.
then that's everybody. That's not ours. That's everybody's.
Mm-hmm.
I mean, when I say everybody, I mean newts and flies. And
Right, and that's what I mean, that's what I would imagine
Alright.
would be the concern. The ozone's nearly repaired, right?
Yeah. And we will spend time talking about how the marvel of 1950s and 1960s chemistry, and it really was a marvel at the time, backfired, and in the 70s it was spotted and worried about and preached about, and in the 80s they took action, and it's been 40 something years now. And things are looking better. They are. And we might, there's room there to kind of discuss. It's kind of outside the boundaries of experimental science because we don't know the full answer, because the full answer is too complicated. But you'll hear people saying, "Oh, the Earth is healing itself." It's too complicated for us to actually pin that down, but sure.
Mm-hmm.
So we can think about some processes by which that happens.
Fossil fuels, I guess, I mean, they use sort of the, extract, there's a whole, there's so many layers to that, I can't even begin.
We are not going to get out of a one semester class in environmental chemistry without having to mention our continued reliance on fossil fuels. And what specifically are you worried about?
Well, extraction is one concern.
Extraction in the sense of it's damaging to remove them, or we're removing them and they will be gone.
It's geologically, in a geological sense, doesn't have an effect on the planet, and like the removal of fossil fuels causing this is my internet knowledge. It's
Yeah.
my Wikipedia
So,
brain.
have you ever seen? There are things. The Earth is a very strange place, and it is resilient up to a point. But have you ever seen a salt mine, or even a coal mine?
I saw one on a TV show.
They go way down deep underground, and then they just dig out cubic acres worth, hectares worth of real estate and bring it to the surface and then burn it, and it's gone. And now there's empty space underneath the ground with millions of tons of pressure pushing down on it. How is that going to resolve itself? And the
Seismic activity.
in the oil supply, the way that we get oil out of the ground, the way that we get other minerals out of the ground, often involves us so the oil's a liquid. We replace that liquid with another liquid. But yeah, yeah, there are geological things to worry about. I'm not sure our book has even included that concern in its scope, but yeah, it's a real thing, and I worry about that myself from time to time.
Mhm.
What else about the fossil fuels?
The burning, right? Like burning of, or the use and the conversion, I guess, right?
Mhm. What about the conversion?
Well, we take fossil fuels and we use that, and then we do a bunch of chemical reactions to get petrol, gas, and then our cars use the gas and we burn it, and then that hurts the environment some more. Emissions.
And it's not just that we're creating emissions. It's the fact that we might be doing it too early in the technology life cycle, because we're doing it incredibly inefficiently. You know, maybe we discovered oil too soon.
I think we learned that actually in physics,
Yeah.
like how inefficient, like the energy, like the use of fuel and, or like the combustion and stuff, it's so inefficient.
We can look at, so in computers have really aided the design of turbines, and AI might even make another leap in turbine design. The numbers in the 80s and 90s for power stations, fossil fuel powered electrical generating power stations, were about 45% efficient. We're losing more energy than we're converting. Most of that is lost in the process of burning the fuel to heat water, to make steam, to turn the turbine. It's all in that middle part of the energy generation cycle. It's not in the turbine to electromagnetic energy part. It's in the steam turbine. So we can look at what the modern numbers are for that. I bet it might have gone up two digits, but it's not going to be. It's not going to be a good, like what we see in biology is really efficient use, really efficient conversion of one energy form into another. It's not going to be on the level of biology yet. And by the time that the technology arrives, we might be out of fuel.
I was like,
It could be an irony. Okay, what else we got?
Climate change? No.
Okay.
yeah, I mean, yeah.
I mean, it's staring us right in the face. There's data out there. There's graphical data, and there are people who want to pull that data to their side of the argument or push the data to the other side of the argument. We'll take a look and we'll see if it makes sense about what's going on. And if we can pin a cause and effect together, I think there is one in there. And there's a couple of things that people don't talk about. In terms of emissions being the key here, because there's a couple of things going on in the world right now that are more complicated than just, oh, my car has a petrol engine and my car is contributing to climate change. There's a few other things. We'll see how far we can delve into that.
Data centers and overpopulation, or like urbanization is like changing the They're sinking on the coast?
This is a double-edged sword
Ah.
because we hate it, and we also love it. In the past 2 weeks, they're digging in my neighborhood. They put the cable in front of my house last week for Google Fiber. Couldn't be happier, because now I get like massively fast internet in my house. But then that also goes with Google is consuming electricity at a phenomenal rate. And AI is pushing this to a level of consumption that we've not seen before.
I was like, I don't even think we actually know the full picture behind it yet at all. Like,
So they're building data centers all over Texas. And that requires resources. So that will not be in our book.
No.
That will not be in any textbook because this is new.
it's like literally
Yeah,
3
if
years.
you want to go explore this, someone will have already, somebody's already had this thought, but this will be new. This could be a topic for you to go and satisfy your own curiosity with. Now I'm going to lump those together. So data centers are a big consumer of resources. Urbanization
That's so much, that's a lot to that.
is we can talk. There's an awful lot to think about there because in some ways it becomes more efficient when you put resources closer to each other. You should be able to make them be more efficient. Now, has anybody been on 183 recently?
I have a video of me screaming on the toll road. There's a video of me driving going, "Wee!"
When I first moved back to Texas, 183 was 2 lanes in both directions. It's now 7 lanes with the toll road. Where did they get that real estate from? It was the big grassy median that the hawks used to sit on top of the light posts. I used to enjoy watching the hawks just sit there and prey on the rabbits, I guess.
And the small
I'm not
birds,
sure that we
they're
have,
like-
they're eating something.
they eat little birds.
There's no rabbits in my neighborhood because the soil is too shallow, but there must be somewhere. Anyway, or birds, they eat birds.
Cats.
There's no cats in the median.
No kidding.
Yeah, anyway. One of the things about urbanization that we haven't learned, we've refused to learn. I was in Houston at the weekend, where 610, where it meets 10, is 8 or 10 lanes wide in both directions,
I think it's like 10.
and was the only slow part of my journey. I went from Austin to Galveston, and the only time I went slow was on the 8-lane highway. Making capacity does not ease congestion.
California would like a word.
It just obliterates what is already there. So we don't have that median with the hawks in it now. They've been displaced. They have to find their food somewhere else. And it doesn't. It encourages when you build capacity. It encourages people to drive on that arterial route, which then causes more congestion. So it's a self-fulfilling prophecy. Yeah. All right. Anything?
Pesticides, microplastics.
Okay, let's
Just keep going through the list in my head, I have a carousel
Okay.
of stuff.
let's jot those down, and we'll come back to them, because this could last several days of us just spitballing and thinking. First.
I don't know, I don't really have any, to be honest.
Okay.
Honestly, I think that's all from me.
Okay. All right, back to Nicole.
You have a lot.
This is like what I wanna do with my career though.
That makes sense.
I've genuinely been very interested in this for a long time.
So we're worried about pesticides. In what way? Pesticides good, no?
Yeah, sure.
This book, I haven't cracked it open to see, but that book will probably say your kids are gonna love living in the future because of pesticides.
Runoff, so, water systems, and it kind of goes back to water
So
systems.
why are we worried about that? There are things that I care a little bit about pesticides is the lack of specificity of. None of you are old enough, but it used to be when you drove from Galveston to Austin at nighttime, when you got home, your car was absolutely covered in dead bugs. Because there were lots of flying insects. And now there's not. There's not. There's just quantifiably not dead insects on our cars anymore. Your kids are gonna love not having to wash their car every time they drive it at night. Because pesticides are gonna stop the flying bugs. Everyone hates bugs. Except we now all love bees. We used to not love bees because people were stupid and didn't know that bees weren't wasps. And they thought that bees were bad. They really did. And we kind of recognized, oh, pollinators. Pesticides, that runoff is going into somebody's water. That water could be not just the system, but it could be a supply. And we have the indiscriminate effect on pollinators. And our little research on local honey found that one store-bought honey had a very prominent peak for a 1,4-dichlorobenzene. That's kind of something that you would find in antibacterial soap, possibly, or in a pesticide, because it's antimicrobial. Why is there an antimicrobial agent in somebody's honey? Because a farmer sprayed their field with pesticide, and the bees foraged in that field. Okay.
Plastics, microplastics, manufacturing.
Oh, we made some microplastics this afternoon. I was making a little, the acetone bottle that we finished using this morning in lab. I decided we'll cut the bottle off that plastic bottle, we'll cut the bottom out of this plastic bottle, and we'll use it as an ice bath. And in doing so, little fragments of plastic were on the bench top. And so we made some microplastic, because those will get wiped into the trash can. The trash can will go to a dump, and that plastic is out there. So, we're worried about plastics and microplastics. Why are we worried about them? The next word on the board is an important word, and it's going to subdivide some of our concerns. Some of our concerns belong in this camp, and some of our concerns belong somewhere else. Why are you worried about the plastics?
Because of their, I'm trying to think of the word I wanted to use, but, infiltration, I don't know, like, that's the best.
The fact that they just kind of get everywhere,
In our heart?
and they can be ingested, and then we have no metabolism to get rid of them, which means that they have they are mostly harmless, but we have them forever. They're not going away. It's going to take them a really long time to get degraded back to a form where they can be metabolized and reincorporated into nature. Plastic. Let me remind you, your kids are going to love living in the future, because plastics are going to save them. We're going to be able to do things with plastics that you used to have to do with metal. And metal is costly, and metal rusts, but the plastics, they will live forever. Those words are still ringing hollow in somebody's ears. The fact that they're going to live forever, there's a class of chemicals now that people just call forever chemicals. We made them to be tough. They were built to do a job, and they do that job phenomenally well. And they're built not to degrade.
Don't we see those in cars?
We now see this as an issue. They're all over the place. Forever chemicals. There's a big one that has a brand name.
Has a what?
Brand name.
Oh, Teflon? Or?
Teflon.
Yeah.
Teflon is a forever chemical. It's non-stick, meaning nothing grabs onto it. Nothing degrades it. It doesn't respond to acids or bases. And in the chemical world, that's it. You've got acids or bases. And yeah,
So
it is.
when the pan ships and then you consume the Teflon, it stays in.
Yeah. Yeah. But they sprayed it on pans, and they convinced the world that everybody needs this, because your eggs won't stick to the frying pan anymore. So that 15 seconds twice a week that you save is enough for you to replace your cookware. And you're keeping up with the Joneses. Your neighbor has Teflon pans. You should have Teflon pans too. And that Teflon's not going anywhere. And if you scrape it, if you don't use a plastic utensil with your Teflon pans, and you use a fork to scrape your eggs, you now scratch the Teflon, you ingest the Teflon, it's now in you, There is no metabolism to get it out of you.
Nothing can latch.
So it's in you forever.
It's not in just you forever, it's in your children.
Yeah.
Because the Teflon can travel through the umbilical cord into unborn children.
They're
Teflon was
finding
found in
brand new
umbilical
children,
blood.
brand new children are finding microplastics in their hearts,
Yeah.
in their bodies.
Now, does it matter? We don't know yet because it's only 60 years old.
If the average lifespan of the human increases by 20 years though down the road, we're gonna have a really good answer. We're being told.
We might need a little bit more time. We might need a little bit more time. We don't know. We don't know yet.
So short-lived versus
Okay, so we're worried about the balance of our ecological systems. We're worried about pollution. We're worried about the water system. We're worried about removal of fossil fuels and then converting them into something else, which gives us emissions which are pollution, but it also gives us emission that contributes here. There's another thing missing here, because why do we burn the fuel in the first place?
for machinery, or energy.
Yeah. To release the energy. So you are releasing energy. Where does that energy go? Into the environment. You've all seen the Australian video clip about the oil tanker whose front fell off. Before the term ends, we'll watch it more than once. There's a comedy video of Australian news interview about an oil tanker who breaks up at sea and the front falls off. And it releases the oil. And where did the oil go? Well, the oil went into the environment. And the news reporter asks, well, aren't you worried about that? You know, well, we're going to drag the tanker away from the environment. Yeah.
Love it.
Okay. And then these are new. This is like a lack. We're building resources, but we're losing resources. It's a balance. You can't just gain something. In order to gain something, you have to lose something. In order to gain a new neighborhood of affordable houses, you have to lose the field that you were grazing cattle in.
I think we just talked about this, no, Kim? Something about trading.
It's a substitution.
Yeah.
Yeah, it's a substitution. You're just substituting from one to another.
And then we have these chemicals, which may or may not be soluble in water. But they're finding, there are physical forces at play that will dislodge an item from one place to another. Like hard rain will move soil from one place to the other. The soil is not soluble in the water. But then we've got the situation where stuff can dissolve and then run off. So we've got surface stuff at play versus subsurface things as well. And then we have the longevity of these forever chemicals that are man-made, purely new chemicals. Chemicals that are so new that our biology has no response for. They're unmetabolized. And then, are we even concerned about what that does? Have you ever looked at the weather reports? Either on the internet or on TV? And it says, here's the weather map. I'm going to have to write in Fahrenheit.
Oh.
Scientists don't use Fahrenheit. But it will say it's 90 here, and it's 90 there, and it's 91 here. Here's town. What's the temperature in town? Isn't the temperature just the temperature? Isn't it ambient? Isn't it just part of a system and everything has the same temperature?
Urbanization.
No. No. I have a localized climate right here. And if the differential between that and this is big, then we have an issue. Let's do this again. Only it's not Austin. It's Phoenix, Arizona.
Oh, what are we doing, 105? Where are we at, 115?
Not only is the climate here different in terms of temperature, it's wildly different in town than it is out of town. Have you ever been to Phoenix, Arizona?
Unfortunately.
They have public transport.
That's all
That's
they have though.
good, right?
I don't like Phoenix.
It's bus. Bus is still diesel powered. And here's the bus shelter. Because it's very, very sunny, they put an actual shelter and people stand and wait for the bus under the shelter and the bus comes. Have you seen the bus shelters in Phoenix, Arizona?
Mm-hmm. Well, we have them in Portland, but for other reasons.
What else? What else do they have in Phoenix, Arizona at the bus shelters?
Water, fans.
They have water sprinklers. This bus shelter is sprinkling water because evaporation causes cooling. They sprinkle water out, that water picks up, mops up the heat, and then evaporates. Which means there is a humidity bubble over the entire city. Arizona is an arid state. Phoenix, Arizona is a humid microclimate completely foreign to the rest of the state. There are other things that we can worry about along with that. Have you ever seen, I was down in Corpus Christi a week ago, massive wind farms. You ever seen the wind farms down there?
Mm-hmm.
Hundreds and hundreds of wind turbines. Have you ever seen wind, like humid air, come in off the sea and go through the wind turbines?
Maybe.
We'll pull out some video because when the wind that has energy exerts a force on the blades of the turbine to make the turbine move, thereby doing work, and then that work turns a magnet inside a coil, or a coil inside a magnet, and generates electricity that way. That work means that the moist air loses energy, which is enough to make the air immediately downstream from the wind farm cloud. If I have a farm that grows crops and it's here, and I rely on rain to rain on my field at regular intervals, and then somebody builds a wind turbine here, now it might just rain here. This is an actual thing. And that this is good. We cannot complain about this being good. We can. There's a whole list of things that can be improved. But this is a really good idea. Unless you're that guy whose land is now worth less because there's a microclimate right here. They used to rely on the rainfall there, and it's no longer coming to me. Possible.
It's also hurting the ecosystem balance. It
It is?
stops the whales from migrating. They're finding that it's like has a direct effect. The ones in the water, not
Yeah.
obviously not the ones.
Is it because they make a whining noise?
Something, it is actually something about the noise. There's something with the noise that has, it's something to do with the
Okay.
whales. Yeah, that's off the coast of Delaware, they've been fighting putting in a turbine. Like, they really wanna put it there right off the coast, but they have a bunch of people fighting it because it's had a. like-
Which Delaware senator lives on the coast and doesn't want it in his sightline?
That's exactly, yeah, I don't know.
Because you know, the senator from Massachusetts. I'm recording this, so I'll be very careful about what I say. You know, the one that's the brother of those two other very, very famous politicians that both met unfortunate ends.
Mm-hmm.
He was pro alternative energy, but blocked a wind turbine farm that would spoil the view from his coastline estate. Yeah. There's the whole
Yeah, sorry.
not in my backyard. Yes. You can have wind turbines. You can have alternative energy. You can have data centers. You can have solar farms. But you can't have them anywhere near my property because I'm worried about my property value. Not in my backyard. Okay, so I made a very, really short list of things that I could think of. And how we can collate these concerns that I was just assuming that you would all generate into categories. One of my categories is longevity. I'm worried about things that are going to outlive me and have consequences for my family or for other people, not just, you know, they don't have to be related to me. I care enough about the world and animals that worried about the world that I'm going to leave behind. This, okay, this ties in. Where on the board does that tie in?
I mean, a bunch of them, I feel like.
Yeah. Once they made 183 be 7 lanes, is it going back to being 2 lanes each way ever? Ever? No.
And they're doing it everywhere. I mean, at the 360 bridge, they're adding
Yep.
a bunch of lanes.
I know, me driving home.
They're
every day,
never
so-
gonna undo it.
Yeah, and 35, where I live right next to,
Sadly, you will not live long enough to see I-35 finished.
you know what, it's fine, I wanna be away from I-35.
Too much traffic.
These are issues of longevity.
Mhm.
This is an issue
Well,
of
it's right now.
longevity. Yeah. Well, in terms of, actually, the worry is the other way around. The
Oh, yeah,
worry
they'll run out
is
before.
we'll use those resources foolishly.
Mhm.
The worry is 70 years from now, someone will say, I've found a fabulous use for coal.
It's 100% efficiency. Yeah.
And you go, you're 140 years too late, my friend.
But that's,
Sure. Yeah. It ties into some things better than others, but you can apply that all over. Another word, has it been on the board yet? That I'm worried about?
yeah.
So the obvious one for the longest time has been fossil fuels. We, the Western nations, are now consuming much less coal than we ever consumed before. We're still consuming oil, still consuming natural gas. Natural gas is better, it's cleaner. Coal is really dirty because we have issues with not just the problem of efficiency and emissions, we've got particulate emissions. When I was young, the landmark buildings in London were black. And I thought they were just black buildings. No, they were dirty. They were dirty from the smoke pollution because when I was a child, the houses in my street had coal fires. And there was a certain smell, especially in the winter months when the air was cold and damp, and the smell of coal is something that I associate with winter and Christmas. But it is very, very dirty and very full of particulate matter. And that means health concerns, not just for the people who mine it, but for the people who live in the places where we use it.
Cause strokes.
Here's a buzzword that I included. Contamination. Contamination. All right. What fits? Obviously. We wouldn't, if the water's good, we wouldn't be worried about it. We're not worried about the fuel itself being contaminated. We accept that there's a certain amount of sulfur
But if
in
the oil
the
tanker
coal
breaks
and
something
the oil.
in the water, then it's
Yeah.
a contamination issue.
Here? No, it doesn't really fit. It doesn't really fit.
No, technically not, I guess.
It's kind of emissions, and the emissions are foreign, so maybe it could. You could crowbar that one in. Yeah, I mean, what it does, not the pesticides themselves being contaminated, but maybe your food supply is contaminated by the pesticide. Yeah, and then microplastics. now being ubiquitous levels of contamination. So, when we think about contamination, because this is where we're going to pick it up on Thursday, we'll try and make sense of where this goes. If you contaminate something, at some point, the thing that you contaminated was not contaminated. So the big picture is purity. And this is now where chemistry can step in and say, that's a word I know. This is a chemistry word. I know when things are pure, and I know when things are not pure. So when we start building our universe of knowledge that we can apply the information in the textbook to, we're probably going to start right at the very, very beginning of what does it mean to be pure. And everything in the universe is matter, and all matter is chemicals. Okay, so that's probably where we're going to start. There's two words that we have. There's one word that's been on the board, but we didn't dwell on it. It's this one. That one. Instead of thinking about the world of things, maybe we should think kind of abstractly in the world of energy, not just usage, but what energy is and how it interacts with matter itself. Because there are multiple forms of energy and there are multiple forms of matter. And it requires a specific type of energy to interact with a specific type of matter. It's the ultraviolet from the sun that interacts with ozone that does something fancy that protects us from the ultraviolet from the sun. The infrared from the sun doesn't interact with ozone the same way that the ultraviolet does. They're two completely separate things, okay? So I'm going to include this as interactions. With energy. And then there's a massive topic that never made it to the board. Massive topic. And we might have said it in terms of what we mean, but it never got written down. If I'm worried about us using, we did say this, worried that we might be using this too soon. And then I would like to hold on to it. Maybe we can find a way to use less, recycle. And I said there was a couple of things in the book that I was looking for, but I didn't look really hard. I kind of looked in the index to see, show me where these things are that I know have to be in an environmental science book. And they weren't immediately there. Nature recycles for us. We need to know about the carbon cycle and the nitrogen cycle and the water cycle. And the index didn't include carbon cycle, and that's as far as I looked.
That's one even simpler.
There are, of course, other concerns. There's one massive concern environmentally that is not on the board. That is the concern from radioactive material. Our book does talk about radioactivity. Without revealing, I'm recording this, so we won't say anything out loud. But show of hands, as people of this generation, Are you pro nuclear energy? Yes or no? If you are, raise your hand. Okay. People of my generation, it was very, very clear what the answer to that question was. It was shockingly clear that we were a big, fat no. Not me, but my generation. And there are logos. There would be memes now. Memes didn't exist. And slogans that have faded into history that nobody knows about the anti-nuclear campaign that was Europe-wide. If you owned a Volkswagen, you definitely had a sticker on the back of your Volkswagen that was a little sun. It was an orange and yellow sun with a smiley face, and it said Atomkraft 9 Danke. Nuclear energy? No, thank you. Yeah. My generation was deeply, deeply against nuclear energy. This current generation is actually pro. They see it as being clean, they see it as being safe. I lived through a couple of nuclear disasters and the threat of imminent nuclear war in the 1980s. So, it was a little bit different.
Chernobyl, 3 Mile.
Yeah. All the word, that Chernobyl HBO docuseries, watch it, but
I've seen it.
be prepared to have to take a break. Most of the words that we need are on all of the words that we need are on the board. Thursday, let's collate those down, see if we can put them into sub-lists, pick one of the lists, drill down on what it means. We'll probably start here because it's the one that makes the most sense. We'll talk about what is pure, what does it mean to be a pure chemical, what kind of chemicals are there, what families do you belong to, why don't these families want to be together, why do they want to be separate, and then we'll do 1 or 2 of those, and then we'll hit the book, because we're not ready to jump into chapter 1 yet. Okay?
Okay.
Yes, sir.
All right.
Sweet.
See you Thursday.
Thank you.
Thank you.